I have a brief video for determining how to figure out the overlap of an injection site in the brain with the brain region that you're injecting it into. Because sometimes injection sites can be rather large and they can sort of bleed out of the brain region of interest. And so this can be a problem because, as you might imagine, we can't know if, let's say, we're doing retrograde tracing, whether this is a problem that's solely happening in the injection site or if it's actually labeling stuff based on its injection into the neighboring areas. So we need to know this for sure. So let's take a closer look. Okay, so first order of business is we want to take our image and take a closer look at it. We want to open up a injection site picture in ImageJ. In this project, we injected multiple retrograde tracers into the same brain and then highlighted them with immunofluorescence. And so in this picture, we're going to see evidence of a lot of stuff going on of that nature. So open ImageJ. Now, to orient you to the image here, we have red labeling represent an injection of fluorogold, a retrograde tracer. Green is also a different retrograde tracer, cholera toxin subunit B, non-toxic, of course. We don't have the injection site here. This is just a lot of labeled fibers, but presumably the injection site is somewhere behind it over here in the spot. You also notice that there's a blue coloring that is kind of throughout this picture, as well as more so toward the right edge. That is a fluorescent Nissl stain. So there are substances like neurotrace dyes that will do this fluorescent Nissl stain. And additionally, other things that can be used are things like a DAPI counter stain that is normally blue. So these are not the average colors of all these things. These are all pseudo-colored to help them all overlay into the same image. What we want to determine is how much of this red blob injection site exists within the ventral palatum and how much of it spills outside of the ventral palatum. Knowing this percentage might be able to help us determine maybe how much there is a correlation of the injection site's location within the ventral palatum versus the amount of labeled cells in other parts of the brain. Let's give it a go. So in ImageJ, we have a few functions we could play around with. Most notably, we have drawing tools that will be very helpful for us. What we're going to do first is we're going to do a polygon drawing tool to highlight the injection site. We can zoom in by just hitting Control+ while holding our cursor over the area of interest. And I'm going to just crudely draw around what appears to be the edges of the injection site. So this can do with a polygon. You can do it with ellipse if it's more circular. I'm going to do ellipse in this case. And then we'll just pinch it around as needed. So we can hover it over where it turns into a hand, and then click and drag to scrunch it down from each of these points here. And that seems to fit it about right. Again, to get a cleaner fit, you could always do polygon instead and just kind of click around each of the vertices as you're going around. So what do we do now? Well, we go back to our ImageJ tool panel, and we can do analyze. So we do measure. So it says here that the area is 3.8. And this is in an image that has been converted to inches, interestingly. I'm not sure at what point this was done, but we don't really need to worry about units terribly much. So whatever the units are from one version of the picture to another, they have to be the same units. So this starting image, it's in inches. So in the next image, it should also be in inches. All right, you may want to take this information down, copy it into a spreadsheet. The reason being because this is not the only important number, this area measurement. We also may want to know exactly where the coordinates of the selection are. So this ellipse, where we placed it by this bx and by, those are x and y coordinates. And the width and height tell us the approximate diameters going lengthwise and height-wise across this ellipse that I've drawn here. All right, so this set of results, though, it will stay for the remainder. We'll just hide this for now. And we can get rid of the selection by just clicking briefly on something else. All right, well, that's nice. That's all well and good. But of course, that doesn't help us determine how much of the injection falls within our brain area of interest, especially because we don't have the area of interest highlighted. Ideally, with some sort of brain region, you might want to stain it with some marker that really highlights it best. In the case of the ventral palatum, something like substance P staining with immunofluorescence might have been best, but there are only so many colors and stains you might be able to use at your disposal. And Nissl staining may be equally effective if you can just tease out what you're looking at. All right. Hopefully, when going through your various images, you've been able to determine approximately which page the image falls on. You can usually do this by looking at certain landmarks and things like the ventricles, things like white matter tracts, like this anterior commissure kind of looks like a sperm thing here, and the general outline of the brain shape as well. When I say page, I'm referring to the Rat Brain Atlas right here. So we have our handy dandy Rat Brain Atlas, 6th edition in this case. We go to the coronal sections area. We try to find something that has comparable landmarks. Again, you might be lucky and have the files already named with the page number that the slices or brain sections correspond to. And so that might help orient you to which figure to select in the top right corner. But if not, you might have to kind of figure it out on your own. In this case, we have a brain slice that has this little shape to the anterior commissure. Let's go ahead and zoom in on that a lot. Use a hand tool to drag it down. So this being the anterior commissure, we'll do a quick side-by-side. This and this kind of match up with each other shape-wise relatively well. And this is below the ventricles, sort of solid blue shape here. So this might be the right page to pick here. Additionally, we have the ventral palatum. Notice the ventral palatum isn't right below the below the anterior commissure, but it is situated nearby. And it's not right against the bottom edge of the brain because we have these other structures such as the olfactory tubercle and the horizontal limb of the diagonal band. It's very lengthy name here. Region of interest in this specific case is our ventral palatum here. Ideally, we can use the Nissl stain. We can also use this other shape as a support to help us determine where exactly we're looking, because it so happens that the tracing seemed to highlight things in the interstitial nucleus of the anterior commissure, as well as the bed nucleus of the stria terminalis, these ST areas here. So that highlights this in green, saying, okay, this is not ventral palatum here. That's lucky for us. Might not always work out that way. So let's try to get our Nissl stain going on here. How do we do that? Well, I mentioned our Nissl stain is going to be in blue. And the blue is in the picture, but we can't really see it. There's too much stuff here. So let's separate out blue. We go to Image, Color, Split Channels to split the 3 color channels. In this case, we have the blue popped up right here. We also have red and green as separate images respectively in other windows. So for instance, the red, we see the blob there, but a lot of the rest of the picture has been removed. The green, we see that same sort of patterning here. The blue is what we care about because that's the channel that I said our Nissl stain is on already. So using this Nissl staining pattern, we're just going to try to scrunch this up, zoom in on it. Not too close, just far enough away. we will bring up our rat brain atlas again. And we'll want to generally match not only the shape of this, but match it with the atlas's own plate view. So the atlas has these things called plates, which are just the Nissl stained sections that correspond to this page of the atlas. This page of the atlas happens to be page 30, figure 30. So we want to find the matching Nissl trace for that. So we take into our mind this shape of the ventral palatum here, and where it generally exists in relation to the anterior commissure, and this bottom edge of the brain. We then click on this little button here that says plate, and it forwards us straight to the plate view. We zoom in, and we can kind of see the outline to the ventral palatum here. It is a little tricky to make out completely, so let me help trace it out with some annotation tools here, if Zoom will let me do so. So the ventral palatum appears to be approximately along here for reference. It's not the greatest trace, but again, this is just annotating in Zoom. This will disappear in a second. We could try to compare and contrast and see how bad my drawing is by flipping back to the atlas page. So let me just zoom out. One moment, close this, select this, zoom out. Got this terrible looking blob here. Let's flip back to the figure and zoom back in and see how well I determined it based on what I was seeing. And a little bit closer and a little more. Okay. This is approximately what I was seeing there. I might have over-selected based on what I was trying to visualize. So there might have been some issue with that. There also might be some issue trying to differentiate the substantia nominata SIB here from the ventral palatum. This is a small enough region on this page that I'm not too concerned, but we do want to take these things into mind if we separate this out into a more fine-grained analysis later. In any case, it seems that I didn't quite include the smaller parts off to the side down here. The ventral palatum might not have the same Nissl staining throughout. So let's go back to the plate view and see if I could rematch this up again. And then maybe try to fix this accordingly. This will help kind of train us into seeing what we need to see here. So, oh goodness. Page 30. Alrighty. So based on what we got here, from what we saw in the atlas, we want to actually nix this little chunk here, probably some of this chunk here, but then also extend it to go down a little further over through here. So that's approximately where the ventral palatum should be. Let's see how well we could trace it over here for our reference. So just gonna click off of annotations. Gonna need to magnify this, I think, a touch more to make the anterior commissure about the same size. Okay, so the anterior commissure is right about here. And if we expand the window a tiny bit in both directions, yeah, this is a bit too zoomed in, so let's zoom out. Use a hand tool to pan this down. It seems that the anterior, the ventral palatum is taking up the space that is around here or so. So we're going to try to trace it using the Polygon tool that I clicked on above. So we're going to trace it through here. And it seems to terminate about here based on the Nissl pattern. This may be a bit premature, but this is also well beyond where the injection site is. So I'm not too concerned about getting the whole ventral palatum. The injection site is actually around where this tract mark is here in the brain. So I'm just going to cut it short and just follow the image here. You can kind of see the boundaries of this Nissl stain for the ventral palatum because you can see the larger cells grouped up here and then smaller cells grouped here that kind of designate a different brain region beneath it. So let's give this whole thing a try. I'm going to get rid of the annotation for now, just because it's going to be obscuring our view anyway. Now we have our trace. The only problem is that this selection, because ImageJ only really likes having one selection available at a time, it will wipe this if we do anything else with the image. So we got to fix that. What we can do is we go to Image, Overlay, Add Selection. So now it's added that selection to its quote overlay. Now we should be able to add that overlay to the ROI manager. Stands for region of interest. We add it to the ROI manager, and now this whole selection is sort of entry 1 on this ROI manager, meaning that we can recall it very quickly as entry 1 on any subsequent pictures of the same size and shape. Now, what I'm going to do is I'm going to go back to Image, Color, and then we can merge the channels back together. So let's go ahead and do that. We got red to red, green to green, blue to blue. Good there. We will create a composite. You don't necessarily have to do that. It'll merge them together into a non-composite image. That's just a flat image rather than like a multi-part, like layered image. You can choose whether or not you want to keep the source images. You can have them to refer to. You might want to keep them, so we're just going to check that. Hit OK. So now we got this back together again. Notice that it has this weird slider for like the different channels, but it doesn't separate them out necessarily. For simplicity, we're going to say image, color, stack to RGB, and it creates a more flattened image. They look the same, but there is that slight difference of having not the multiple layers in the image. All right. So now what we do next is we hit the ROI manager's entry, just click on that first entry, and it plops it right where we want it to be. That's pretty neat. Still, though, we need to trace the amount of the injection that's within this area. And like I said, it doesn't like doing multiple selections in ImageJ. So how do we isolate that? Well, we can do this function here. I don't recommend cropping down to this area because it doesn't cleanly crop all around this polygon that we've drawn here. Instead, it just crops to the outermost edges on the left, top, bottom, and right. And it still keeps the stuff sort of outside that in existence. Instead, what we're going to do is we're going to go to Edit, Clear Outside. Now it's eliminated everything outside of the VP section that we've drawn. So we're going to zoom in on that, a little bit of Control+. And now even if we lose a selection by clicking elsewhere, it's not a big deal because all we have left is the VP itself. So I'm just going to click. And then we can do a quick polygon selection tool click thing there. Just kind of make it as round as possible, even though we're going to have to cut it right here. Follow along the edge of the ventral palatum. Bring it down in here. Okay, follow this along as best we can. And link it with that one. Now we have the amount of the injection site that exists only within the ventral palatum. We go to Analyze, Measure, and we find our results window. It's hiding in this case. We have a new set of results. So this is just the area that we selected here. So this is the area of the blob that's within the ventral palatum only. So to figure out the amount of injection site that exists solely within the ventral palatum in this page, we then finally go to a calculator real quick. And we do 2.155 divided by 3.800. Just times 100 to get a percentage. So 56.71% of the injection site exists within the ventral palatum in this case, meaning that the remaining other part of the 100%, about 43.3%, exists outside the ventral palatum, either above for below it to some extent. So this is good information now. And it might be helpful to, again, copy paste both of these lines to a spreadsheet, because this will tell us exactly where we've localized our selections in both of these cases. One last thing that might be helpful to also record is, in case we're trying to figure out, okay, well, we know how much of the injection site occurred within the ventral palatum. A different question you could ask is, how much of the ventral palatum was labeled with the injection on this page? So that's sort of like the reverse question, if you will. And that we can kind of determine by figuring out, again, the area of the ventral palatum selection that we made. So assuming we made it correctly, which, in this case, I'm not highly confident that I made it super correctly, but still selected most of the ventral palatum in this case. What we can do is we can click off the selection again. And remember, we have the full size image here. So it should work when we go back to our ROI manager, click on this again, selects exactly the same spot, exactly the same size. We just go to Analyze, Measure once again. And then this third entry is the full area of the ventral palatum on this respective image here, and the locations and width and height of the selection that we've made. So then if you're trying to figure out that other question I asked, how much of the injection site, or how much of the ventral palatum in this case is being filled by the injection site, then you divide that second number, 2.155, over 4.250, and then again times 100 gives us percentage. So about 50% of this ventral palatum area that we have selected here is occupied by a fluorogold injection site. All right, so we can use these percentage numbers to correlate them to labeling amounts that we see in other brain regions. And that can perhaps help tell us what is going on with some of these injections that, they do label other brain regions, but if you have enough of them that are centered in or around the VP and you get a certain pattern, you can correlate those patterns and make certain assumptions about which regions connect to the VP versus surrounding areas of the VP. All right, hopefully this was helpful and instructive. So as always, though, let me know if you have questions.